How about ionic radius? So ionic radius looks like this. The gray represents the atom, and on this side the red is the ion, and on this side the green is the ion. What do I mean by the red is the ion? These are cations, and these guys are anions. So notice what happens here. When we form a cation from lithium, it gets much smaller. Same thing with sodium, same thing with magnesium, same thing with aluminum. Okay, so the cation is much smaller than the atom, whereas an anion gets much larger. Okay, so anion is larger than the atomic radius, and a cation is smaller. Okay, so we need an explanation of this. Let's take lithium again as my example. So remember, 3 plus charges in the nucleus. I've got 2 minus charges in the first shell, and I've got another minus charge in the next shell. Remember, this is 1s2, 2s1. Okay, this is lithium. Now lithium plus looks like this. 3 plus charges in the nucleus, 1s2 in the inner shell, so 2 electrons, and the outer shell is gone now. Okay, use my same shielding screening argument that I just made. Now we're playing soccer, and I've got 3 players playing against 2. What's going to happen? Well, these 2 are not going to be able to resist the 3, so the effect is the whole thing gets pulled in smaller. Okay, so for positive ions, now we have an unbalanced situation. 3 plus charges, 2 minus charges, and the pluses are going to win, and they're going to pull this radius in even tighter. So all cations have less electrons than nuclei, than the protons in the nucleus, so they end up being smaller. How about anions? Let's take oxygen. So oxygen should be regular oxygen is O. Oxygen forms an O2 minus charge, and so the oxygen is going to be 1s2, 2s2, 2p4, I'm sorry. So that's 2, 4, 8. That's got 8 positive charges. And the oxygen 2 minus is going to be still 8 positive charges. 1s2, 2s2, 2p6. Remember, for an anion, it adds extra electrons into that empty shell. So what's going on here? Now we've got 8 plus charges and 10 minus charges. We've got the same core electrons, so it's the same degree of shielding from the core electrons, but now we've added 2 extra electrons. So now these guys are going to be able to roam further away from the nucleus because they want to get away from each other. They're all negative charges. Because we've got this unbalanced situation with 10 electrons, it's now able to be larger than it was before. All right? So second periodic trend, ionic radius, cations are smaller than their anions, or cations are smaller than the atoms, anions are larger than the ions. And a subtle point, but the more negative it is, the smaller they get. Or excuse me, the more negative it is, the larger they get. So this one is bromine minus 1 is 195, selenium minus 2 is 198, 216, 221, 181, 184. These are picometers, by the way. So as we get to more and more negative charges, the size gets bigger and bigger and bigger. And then the opposite is true here. Go lithium, we go 60, 31, 23. These are all in the same row in the periodic table, right? So N is still the same, but you notice it's getting much, much smaller. The reason is it's getting more and more unbalanced. As we lose more and more electrons, it becomes more and more unbalanced with the nucleus, so the size gets even smaller. In other words, this effect gets even worse the more we charge the ion. So the higher the charge, the smaller the radius is going to be for a cation, and the higher the charge, the larger the radius is going to be for an anion. All right, let me say that again. Higher charge basically amplifies this effect. So what I mean by that is the anion gets larger, well, the higher the charge, the bigger still, and cation gets smaller, the higher the charge, the smaller still. All right, so we've covered two trends now. We've covered atomic radius, which we learned going down the periodic table, increases the size, and right to left increases the size. We've done ionic radius, which we learned the cations are smaller, anions are larger, because of this shielding effect. This is the exact same explanation.